Hi everyone, welcome back. Today we're solving minimum removals to balance array. So in this problem, we'll be given an integer array nums and integer k, and we want to make the array balanced, which means that its maximum element is at most k times the minimum element, and we can remove any number of elements from nums to keep it balanced, and we want to return the minimum number of removals that we need to do to make the array balanced. So if we look at this example, we just need to remove 5, and 2 divided by 1 would be equal to k, so we can return 1. In this example, we can keep 6 and 2 and remove 1 and 9, or we can keep 1 and 2 and remove 6 and 9, because 2 divided by 1 is 2 less than 3, and 6 divided by 2 would be 3, which is equal to 3, or we can keep 9 and 6, because 9 divided by 6 is 1.5, which is less than 3. But either way, it would be 2 removals, so we will return 2 as our result. And in this example, 6 divided by 4 is already less than 2, so we don't need to remove anything, and we can return 0. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, we can first sort the array, and then we will set a left pointer and a right pointer both starting at index 0, and we will check if nums of right divided by nums of left is less than k, and while that's true, we will shift the right pointer, and once this is no longer true, then we will update the result by checking if length of the array minus the right minus left pointer is less than the current result, and if it is, then we will update it, and after that we will shift the left pointer by 1, because this would be true once this is no longer true, so that's why we need to shift the left pointer 1 time, and then we will go back to step A again, and then we will repeat this over and over again until the left pointer reaches the end, and then we will return the smallest value of this formula that we have calculated. So let's go over this example real quick. First, we need to sort the array, and we will initialize the result to 4 because that is the length of the array. There will never be more than 4 removals because there's only 4 elements in the array. So left and right start at 0. 1 divided by 1 is less than k, so we shift the right pointer. 2 is less than k, shift right pointer again. Now it is greater than k, so we will take the length of array minus right minus left. 2 minus 0 is 2, and 4 minus 2 is 2, so we can update result to 2, and we'll shift the left pointer. 6 divided by 2 is 3. 3 is equal to k, so we shift the right pointer. Now we will do 9 divided by 2, which is 4.5 greater than k, so we'll shift the left pointer this time, and the calculation we get will still be 2. 3 minus 1 is 2, so this is assuming we remove 9 and 1, and the result is still 2 because that's the smallest we found so far. Shift left pointer. This is less than k, so we'll shift the right pointer. And now that the right pointer has come to the end, our only option is to shift the left pointer. Again, we have to shift left again. And now that we come to the end, we can return 2 as our result. And the time complexity would be O of n log n, because we will need to sort this array. And the space complexity will depend on which sorting algorithm we use. But I will be using the Python built-in sorting algorithm. So for me, it would be O of n. So now let's get to the coding part. So first we'll sort the array, and we'll initialize the result to length of nums, set the right pointer to 0, and we'll iterate with the left pointer. So for left and range length of nums, and we will move the right pointer as long as right is less than length of nums, and nums of right divided by nums of left is less than or equal to k. If that's the case, we'll shift the right pointer, and after moving the right pointer to the rightmost that it can be with the left pointer that it's at, we can check the result. So it will be the minimum of result, or length of nums minus right minus left, and finally we can return result after iterating. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.